Okay guys, so finally the project that I was working, it worked, and this was a 12 volt battery overcharge protection circuit to charge up the batteries. So I'm using an LM7809 and LM7805 regulator ICs to use in series connection to make 14 volts to charge up a 12 volt battery. So in my previous video I already gave a small introduction about this project. So as you can see, it's completely done now, only a few things are left to connect. So you can see each individual transformers has a diode bridge and a capacitor. The capacitor is a 2200 UF capacitor, and after the capacitor the connections are going to get connected on the regulators, and then I'm going to series the output. So this is the finished version. Everything is connected and it's working. So you can see I have connected the regulators, and then I have used a jumper to series both the regulators together, and I have used a small piece of resistance, and from there I have taken the connection, output connection, to charge the battery. So you can see the blue wire is connected on the ground connection of the left regulator, which is a 9 volt regulator, and the red wire is connected on to a resistance which is connected on the positive output of the right regulator, which is a 5 volt regulator. So both the transformers are connected in parallel to the 220 volt input, and the output is then passed through the regulator, and then it's connected in series with this wire in the middle. So you can see there is a resistance that I made using some nichrome wire. So the resistance is a 5 ohm resistance. Now without the resistance the current is too much, so the regulator actually shuts off due to over current protection inside, and that's why no current goes to the battery. So I had to use this small resistance that I made from a nichrome wire, which I got from a regulator, actually from a ceiling fan speed control regulator. So this is the regulator, and on the right side you can see the spring type things that are winded around this ceramic piece. The current is passed through those wires to regulate the speed of the ceiling fan. So these wires are made in the form of a spring. So I took a small piece of it and I tested it for 5 ohms, and then I connected it. So it works pretty well. So the current capacity of the transformer that I said in the previous video, the right side transformer is actually 700 milliamps, and the left one is about a little bit more than 1 amp. So the current capacity of the regulator is 1 amp, so I had to limit the current output with the help of a resistor. So you can see I have attached a heatsink onto the regulator, and you can see the diode bridges are made from 1N4007 diode, and both the capacitors are 2200 UF, and the regulators are on the left side is LM7809 regulator on the left side and LM7805 on the right side. So 9 volt regulator on the left side and 5 volt regulator on the right side. And the heatsink that I'm using here, that aluminum plate is actually, I got that from an aluminum strip that is used to fix water pipes that drains water from the roof to the gutter. So that aluminum strips were used to fix that pipes. So I took a small piece of that aluminum strip and I sliced it according to my needs, drilled 2 holes, and then I attached the regulators into it. So this is the resistance that I'm showing you right now, and this is the output wire that I have connected, that I've attached with this board with the help of some aluminum wire. So the diodes that I have used in this project, I got all these diodes from old circuit boards such as this one. This is a CFL inverter, and I've also used this circuit board. This is an old amplifier, I believe, because I can see some TRS connector. I believe they are called TRS connectors on the left side. So this is an amplifier board, and there are also some other components that I can use later, such as this jack and the small capacitors, which is for another video. So I was talking about the heat sink, which I will show you in a minute, what kind of aluminum strips that I've used. So this is the aluminum strip. So actually they come in 10-foot length, and the plumbers actually cut them in pieces and then they bend them according to the shape of the pipe, and then fix the pipes on the wall to drain the water from the roof to the drain to the gutter. So I took a small piece of that aluminum strip and I drilled 2 holes. I sliced it into 2 small pieces and then drilled 2 holes, and then I used some thermal paste and 2 screws and then attached it. So I've used epoxy to glue everything onto this hardboard. Actually all the components and everything is actually glued. This is a screwdriver attachment that I used to make the holes on that aluminum strip just by twisting it. I did not use any drill machine or any other kind of stuff. I just used the classic way of making holes by hand using a sharp object. Speaking of efficiency, this is not an efficient way of charging battery, because linear regulators uses a lot of power, wastes a lot of power in heat. Very less power comes out from the output, so this is not an efficient way. Plus, if you think of making it with a single transformer, you can do that by using an LM317 regulator IC, which is a variable regulator IC, but you need to attach additional circuitry along with it. So this was the simplest version which I thought of making, because I did not had the LM317 IC with me. Initially I was thinking of using 2 LED drivers, but I did not had working LED drivers, so I used transformer. So now I'm checking the voltage that the transformers are giving out. So you can see it's 19.4142 volts on the transformer output after the diode bridge. So I'm measuring the voltages from the capacitors. So similar voltage is here as well, 19.4. Now I'm measuring the voltage output from the 9-volt regulator. So it's 9.19 volts from the output, and on the other regulator it's around 5 volts, 5.12 volts. So this is what I wanted. So now let's measure the output of the circuit, and it's 14.32. So the float charge voltage of lead acid battery is 14.2 volts, 14.2 volts to 14.5 volts. So this is the adequate charging voltage, and I'm going to connect the battery that I've been using in all other videos. So finally I'm going to charge it with a decent voltage regulated battery protected circuit charger. So I have not tested this circuit yet, so I will test it and I will show you in another video if possible how it works. So before using the resistor for controlling the current, I connected it to the battery directly, and the battery pulls the maximum current that is delivered from the transformer, and the voltage on the transformer output drops, and that's why the current also increases more than 1 ampere. And the regulator has an inner current regulator or current limiting circuit, I believe, or overcurrent protection maybe. So the current actually stops flowing to the battery. It was about 60 milliamps, I believe, 60 or less. So checking the voltage on the regulators and found out that the 5 volt regulator was giving out about 4.5 volts, and on the 9 volt regulator it was giving about 8.5 volts. So that means that it was working more than its capacity, so I had to use a resistance to limit the voltage. So you can see the voltage across the resistance is 1.04 volts. So the resistance is not heating up, that's a good sign. So calculating the power that is going to the battery, that's about 200 milliamps through the resistor, which is under the limit of the regulators. So you can see the 5 volt regulator is at 5.11 volts, and let's see the 9 volt regulator. So it's at 9.19 volts. So both of these regulators are at its limit. And the voltage on the battery is 13.18. So the battery is at its full, almost towards its full. That's why the battery is not pulling that much power, but the regulators are actually at moderate temperature at about 48 to 50 degrees Celsius approximately. The temperature is about like a cup of tea 5 minutes after it was made. So the voltage before the resistance is 14.31 volts, and the voltage after passing through the resistance is 13.31, which is a 1 volt drop. So actually this resistance is limiting the current, or else due to overcurrent the regulators will protect itself and it will limit the current. So the resistance is important here. You need to select the resistance in such a way that it limits the current that is drained from the regulators. So the transformers are not that warm and everything looks okay, so there is a big thumbs up. So now let's go to the schematic. So I've drawn the schematic on an Amazon bill that I've got from a recent purchase. I hate using new things. Instead I love reusing stuff and recycling stuff, such as this paper and the battery charger itself. So you can see the AC voltage 220 volt comes in and goes to these transformers, and then it goes to the diode bridge. So initially I thought of using two LED drivers, 12 volt LED drivers, but the drivers that I had are not good, so I used transformers, and then it goes to the dead bridge or full bridge rectifier, and then it goes to the regulators. So here the left regulator is 5 volt, but actually I made 9 volt the left regulator. And then you can see the connection that makes it series, and then I take the connection out from both the regulators and it becomes series 14 volt DC or 14.3 volt, 3 or 2 volts. So this was it, guys. I hope you enjoyed this video. If so, then hit the like button and share it with your friends, and if you are new, then subscribe to my channel. So thanks a lot for watching. I'll see you later. Have a nice day.